Okay, we are on our last chapter of Unit 3, our last chapter in the Summer Earth Science course. I am going to split Chapter 19 into two pieces because it's rather long, and the topic of this chapter is weather patterns and severe storms. So the first thing we're going to do is talk about air masses. So these are large bodies of air, usually about 1,000 miles across and sometimes several kilometers thick. And they are similar temperature at any given altitude and similar moisture at any altitude. And they move and affect a large portion of a continent while they move. So, just as an example, you can have a cold, dry air mass coming from northern part of Canada. That entire air mass can move down through the middle part of the United States and affect weather throughout that entire region. So these are the size air masses that we're talking about when we talk about an air mass in this chapter. So there has to be a source region for the air mass. So this is the area where an air mass acquires its properties. So there's a way to classify these air masses, and we do it by source region and by nature of the surface in that source region. So there's only a few different types that we can have. We can have a polar air mass, and this will be from high latitudes, and it would have to be cold. We can have a tropical air mass, and this is if we have the air mass originating in low latitudes and it's warm. And those two types of air masses can either form over a continent, so we call those continental air masses, which form over land and are likely to be dry, and then maritime air masses that form over water and tend to be humid, precipitation-forming air masses. All right, so what does that look like? So there's four basic types when you take all that into account. You can have continental polar, so that's an air mass that forms in the cold region over a continent, continental tropical, maritime polar, and maritime tropical. And those two pictures give you an idea about where those air masses can originate during either a winter pattern or a summer pattern. So in North America, the continental polar and maritime tropical air masses are the most important, especially east of the Rockies. So North America, the continental polar air mass is responsible for lake effect snows. So those air masses cross the Great Lakes, air picks up moisture from those lakes, and then snow occurs on the leeward shores or the easterly side of those lakes. And actually, Scranton, Pennsylvania is very often affected by lake effect snow. But New York State, northern Ohio, Michigan, those areas are severely affected by those lake effect snows. So from northern Canada and the interior of Alaska, this is where continental polar air masses originate. So in the winter, they bring cold, dry air, and in the summer months, they bring cool, relieving air. This is just a plot showing you where lake effect snow is really predominant. So you're going to notice that Michigan, New York State, more New England states in the United States are affected. But we are affected in Scranton. We get, on average, 36 to 59 inches of snow due to lake effect snow in the Scranton area. Maritime tropical air masses, so these tend to originate from the Gulf of Mexico and the Atlantic Ocean. So these are warm, moist, unstable air, and they bring precipitation to the eastern United States. We also have some continental tropical air masses to worry about every now and then, and they originate in the southwest of Mexico. These are hot and dry, but these are seldom important outside of those source regions. The maritime polar masses, these bring precipitation to the western mountains, but they occasionally influence the northeastern United States when they could cause what's called a nor'easter in the New England area. And we actually just had a nor'easter this past winter, and it's a little bit more complicated than what this slide is making it out to be. There has to actually be two different fronts colliding there's two different cyclones colliding at one location, and depending on where that is relative to these air masses, you will have a lot of precipitation. But it is possible to happen in the eastern, northeastern part of the United States, and it just happened this year. So we're going to define something called a front. We talked about frontal wedging in a previous chapter, and this is where that's really going to come into play. So fronts are boundaries that separate air masses of different densities. So air masses retain their identities. The warmer, less dense air is forced aloft, and the cooler, dense air acts as a wedge. This is where we have frontal wedging. So a warm front is where warm air replaces cooler air. It's shown on weather maps with a red line with semicircles. They have a small slope. It's usually about 1 to 200 in terms of how high the altitude you would rise per going 200 units in the horizontal direction. Clouds become lower as the front nears, and it's a slower rate of advance, and it's light to moderate precipitation. So typically when a warm front comes in, either it's going to be resulting in a high pressure sunny day, or it's going to be only light to moderate precipitation. We rarely look at warm fronts to see for severe weather. So here's a picture of a warm front going into a cooler location. So this is where the air slowly rises in the air, creating clouds. So these clouds don't rapidly increase altitude, so we rarely have severe weather patterns from warm fronts. So a cold front, on the other hand, this is where cold air replaces warm air. It's shown on a map with a blue line with triangles, and these are twice as steep as the warm fronts, and they advance faster as well. And these are associated with more violent forms of weather. The intensity of the precipitation is greater, but the duration of the precipitation is shorter because it's moving much faster than a warm front. So the weather behind the front is usually dominated by cold air masses, subsiding air, and then clearing conditions. So an example of cold air moving into an area, it rapidly moves warm, moist air aloft, creating those cumulonimbus clouds I mentioned in an earlier chapter, and these clouds are generally associated with severe weather and heavy precipitation. There's some other types of fronts. We have a stationary front. This is flow of air on both sides of the front is almost parallel to the line of the front, and the surface position of the front doesn't move at all. And then we have an occluded front. This is where active cold fronts overtake a warm front, where cold air wedges the warm air upward, and the weather here is often very complex. The precipitation associated with this front is because of the warm air being forced aloft. Okay, so this is just a picture to show how an occluded front is forming. Your book goes into detail about how this actually works, so just make sure you read the chapter 19 on this specific topic about how you form an occluded front. All right, so mid-latitude cyclones. So these are the primary weather producers in the middle latitudes. So you're going to see a anticyclone or a cyclone low pressure system here is usually associated with an occluded front where a warm front and a cold front, or I'm sorry, a warm front and a cold front are intersecting at a location. All right, so the life cycle of mid-latitude cyclones. These form along a front where air masses are moving parallel to the front in opposite directions. So you can have a continental polar air mass is often north of the front, and the maritime tropical air is often south of the front. So the frontal surface takes on a wave shape with low pressure centered at the apex of the wave. The flow of air is counterclockwise, just like I described in chapter 18 for a cyclonic circulation. The warm front and cold front form. The cold front eventually catches up with the warm front and produces an occluded front. The warm sector is displaced aloft and the pressure gradient weakens, and then the front discontinues. So typically when you have these severe weather storms being formed, it's usually a quick event because the cold front overtakes the warm front, and then once the precipitation is over with, essentially a high pressure system usually takes its place. Now, these mid-latitude cyclones move easterly across the United States, and the first sign of their approach are usually in the western sky, and they'll require about 2 to 4 days to pass over a region depending on their speed. And the largest weather contrasts usually occur in the spring. So changes in weather with the passage of a middle latitude cyclone. So you can have a warm front. So warm fronts are associated with clouds become lower and thicker, and they usually take a longer time to pass by, and they're associated with light precipitation. So if you've ever had a few overcast days with drizzly, cold weather, that's usually associated with the warm front. A cold front is where you usually have a wall of dark, tall clouds associated with heavy precipitation, hail, and occasional tornadoes. After the passage of these cold front winds, usually the sky's clear, but the temperatures drop, and usually the weather in that area is associated with a high pressure system. So cloud patterns associated with a cyclone. This is a great picture showing you the relationship between where the air is and what temperature it is at the location of where the warm front and cold front meets, and it shows you the cloud patterns associated with those fronts on the map. And this is an actual satellite image of this exact thing occurring. So you have a cold front and a warm front creating an occlusion shown in purple, and this would be the cloud cover associated with that particular occluded front. All right, the last slide on mid-latitude cyclones. So the role of air. So again, cyclones and anticyclones, they're generated by upper level airflow and maintained by that airflow, and they are typically found adjacent to one another. So you're always typically going to see a high pressure and low pressure associated with each other. So there's always typically a pair of them shown together. And just as a reminder, the cyclone is a low pressure system where you have surface convergent, which gives you an upper flow, which makes air rise and create this severe weather.